Mars fascinates us because it's the most Earth-like planet that we have in the solar system. We see things on it that we can recognize: volcanoes, ancient river channels, sand dunes, polar caps. But at some point we had very divergent histories. And if there was ever life on Mars, something obviously happened to it so that it is not like what we see today. And we really want to know, why did that happen? Why is Earth so unique compared to our neighbor that maybe was like Earth in the past, but is very different from us today? So Martian meteorites are rocks that came from Mars, and we found them here on Earth, and we found 235 of them so far. And this is really interesting because we don't have any samples that we've ever brought back from Mars with any of our robotic missions, and so these are the only pieces of Mars that we actually have here on Earth. They were launched off the planet by probably giant impacts. So an asteroid traveling through space smashes into Mars, launches all sorts of debris all over the place, and some of that manages to escape the gravity well of Mars and make it all the way to Earth. And then it lands somewhere here on Earth where people combing either the deserts of the Sahara or the ice of Antarctica, they can find it and then bring it to a lab so we can determine where that meteorite came from. When I actually get to see a Martian meteorite, it's really exciting because it's a piece of another planet that has come 200 million miles through space to us here on Earth. When we sent the Viking missions to Mars in the 1970s, we were able to analyze the composition of the Martian atmosphere. And these meteorites that we have on Earth, we know they came from Mars because they have little trapped gas bubbles of the atmosphere of Mars inside of them. And it's very different from the atmosphere of Earth. So there's no other way to explain how those gas bubbles got in there. And if we didn't have that data from Viking, we would never have known that these meteorites came from Mars. Generally, we can tell from the composition if a meteorite came from Mars, even if it doesn't have the little trapped gas bubbles in it, because they look very distinct and they generally fall into three categories: shergottites, knocklights, and chassignites. And those are all very different from the regular meteorites that we get from asteroids that are just, say, in the asteroid belts. All of the meteorites that we have from Mars tend to be volcanic, so basaltic rocks that are kind of like the stuff that flow out of the volcanoes on Hawaii here on Earth. And so that doesn't tend to be very magnetic, and so if you saw it just laying out on the ground on Earth, you wouldn't necessarily be able to tell visually that it was different from a volcanic rock that just came from here. The meteorites that we have from Mars show us a lot of pieces of the history of the red planet. Things like hydrated minerals, so stuff with water in it, other types of things that are good chemicals for life to thrive. And we see pieces of that with stuff we've analyzed with the rovers and the orbiters, but we can do a lot more scientific analysis in labs with those physical samples with the meteorites here on Earth, with machinery that we either can't miniaturize to a rover platform, or it's just too expensive to try and do that. I really hope that we get to see humans walking on Mars in my lifetime, just because I want to see some of the big questions about Mars answered, because I really just want to know the big picture. I want to know what it all means, where it all came from. I don't think I'm ever going to go to Mars, but I at least want to see people go there.